Our journey begins at home in our solar system. Imagine you're floating in space, looking at the sun, the heart of our solar system. The sun is a giant ball of burning gas, providing the light and heat necessary for life on Earth. It's a comforting, warm presence in the cold expanse of space. Next, let's drift to Mercury, the smallest and closest planet to the sun. Mercury's surface is covered in craters, much like our moon, and it has no atmosphere to soften the harsh sunlight or shield it from the cold darkness of space. Moving on, we encounter Venus, the hottest planet in our solar system. Shrouded in thick clouds of sulfuric acid, Venus's surface is a scorching 900 degrees Fahrenheit. Despite its inhospitable environment, Venus shines brightly in our night sky, often called the evening star. Now, let's visit Earth, our beautiful blue planet, covered in oceans, teeming with life. Earth is a unique gem in the cosmos. As we float above, we can see the vast continents, the swirling clouds, and the endless seas that make up our home. Leaving Earth, we travel to Mars, the red planet. Mars is a cold desert world with the largest volcano and the deepest canyon in our solar system. The thin atmosphere of Mars gives it a distinctive red color, and scientists are constantly exploring its surface for signs of past life. Next, we reach the gas giants, starting with Jupiter. Jupiter is the largest planet in our solar system, a massive ball of gas with a famous Great Red Spot, a storm larger than Earth that's been raging for centuries. Its many moons, including the volcanic Io and the icy Europa, are worlds unto themselves. Saturn, with its stunning rings, is our next stop. These rings are made of countless ice and rock particles, creating a breathtaking sight. Saturn's largest moon, Titan, has a thick atmosphere and lakes of liquid methane, making it one of the most intriguing places in our solar system. Uranus, an ice giant, orbits on its side, giving it unique seasonal changes. Its bluish-green color comes from methane in its atmosphere. Uranus's moons and faint rings add to its mysterious allure. Finally, we reach Neptune, the farthest planet from the Sun. Neptune is a deep blue world with supersonic winds and a great dark spot, similar to Jupiter's storm. Its moon Triton, with geysers of nitrogen, is a fascinating destination. As we leave our solar system, we pass by the dwarf planet Pluto, once considered the ninth planet. Pluto, with its icy surface and heart-shaped glacier, remains a beloved part of our cosmic neighborhood. Segment 2. The Milky Way Galaxy. Beyond our solar system lies the Milky Way Galaxy, a vast collection of stars, planets, and others. The Milky Way is a barred spiral galaxy with a central bulge and spiral arms extending outward. Imagine drifting through the spiral arms, passing by countless stars of all sizes and colors. Some stars are much larger and brighter than our sun, while others are smaller and cooler. Many of these stars have their own planetary systems, some of which may harbor life. In the heart of the Milky Way lies a supermassive black hole known as Sagittarius Asterisk. This black hole has a mass millions of times that of our sun and exerts a powerful gravitational pull on everything around it. Despite its immense gravity, the region around Sagittarius Asterisk is relatively calm, allowing us to observe its influence on nearby stars. As we explore the galaxy, we encounter nebulae, vast clouds of gas and dust where new stars are born. The Orion Nebula visible to the naked eye from Earth, is one of the most famous star-forming regions. Within these nebulae, gravity pulls the gas and dust together, forming protostars that will eventually ignite and become full-fledged stars. Star clusters are another feature of our galaxy. These groups of stars, bound together by gravity, can be divided into open clusters and globular clusters. Open clusters, like the Pleiades, are relatively young and contain a few hundred stars. Globular clusters, on the other hand, are much older and can contain hundreds of thousands of stars packed tightly together. The Milky Way is also home to many fascinating phenomena, such as pulsars and quasars. Pulsars are rapidly spinning neutron stars that emit beams of radiation, which we detect as regular pulses. Quasars, powered by supermassive black holes, are incredibly bright and can outshine entire galaxies. As we continue our journey through the Milky Way, we marvel at the beauty and complexity of our galaxy, a small part of the vast universe. Segment 3. Exploring other galaxies. Leaving the Milky Way, we set our sights on other galaxies. The universe is filled with billions of galaxies, each with its own unique properties and inhabitants. Our closest neighbor, the Andromeda Galaxy, is a spiral galaxy much like our own. Andromeda is on a collision course with the Milky Way, and in about 4.5 billion years, the two galaxies will merge to form a new, larger galaxy. Elliptical galaxies, such as M87, are massive and contain older, red stars. These galaxies have little gas and dust, meaning few new stars are born within them. M87 is famous for the first ever image of a black hole at its center, captured by the Event Horizon Telescope. Irregular galaxies, like the Large and Small Magellanic Clouds, lack the distinct shape of spiral or elliptical galaxies. These galaxies are often small and gas, making them fertile grounds for star formation. One of the most beautiful galaxies in the universe is the Whirlpool Galaxy. This spiral galaxy, located about 23 million light-years from Earth, is interacting with a smaller companion galaxy, creating stunning tidal streams of gas and dust. As we venture deeper into the cosmos, we encounter galaxy clusters, massive structures containing hundreds or even thousands of galaxies bound together by gravity. The Virgo cluster, for example, is home to more than 2,000 galaxies. In the vast voids between galaxy clusters, we find dark matter and dark energy, mysterious substances that make up most of the universe's mass and energy. Dark matter holds galaxies together, while dark energy drives the expansion of the universe. Exploring other galaxies gives us a sense of the immense scale and diversity of the universe, reminding us of our place in the cosmos. Segment 4. The life cycle of stars. Stars, the building blocks of galaxies, have fascinating life cycles. Let's explore how stars are born, live, and eventually die. Stars begin their lives in nebulae where gas and dust clump together under gravity. As the clump grows denser, it heats up and forms a protostar. When the core temperature reaches a critical point, nuclear fusion ignites and a new star is born. Our Sun is a main sequence star, burning hydrogen into helium in its core. This stable phase can last billions of years. The Sun has been in this phase for about 4.6 billion years and will remain so for another 5 billion years. As a star exhausts its hydrogen fuel, it enters the red giant phase. The core contracts and heats up while the outer layers expand and cool. For the Sun, this phase will result in it swallowing the inner planets, including Earth. In the final stages of a star's life, it sheds its outer layers, creating a planetary nebula. The core remains as a white dwarf, which gradually cools and fades over billions of years. For more massive stars, the end is more dramatic. These stars can explode in a supernova, an incredibly powerful explosion that outshines entire galaxies. The core may collapse into a neutron star or a black hole, depending on its mass. Neutron stars are incredibly dense, with a teaspoon of their material weighing billions of tons. Some neutron stars become pulsars, emitting beams of radiation as they spin rapidly. Black holes, on the other hand, are regions of space where gravity is so strong that nothing, not even light, can escape. The event horizon marks the boundary of a black hole, beyond which everything is pulled in and lost. The life cycle of stars is a testament to the dynamic and ever-changing nature of the universe, with each stage contributing to the cosmic tapestry. Segment 5. The Wonders of Exoplanets. Exoplanets, planets that orbit stars outside our solar system, are one of the most exciting discoveries in astronomy. These distant worlds offer a glimpse into the diversity of planetary systems in the universe. The first confirmed exoplanet, 51 Pegasi b, was discovered in 1995. Since then, thousands of exoplanets have been found, each with its own unique characteristics. Some exoplanets are similar to Jupiter and Saturn, while others are rocky like Earth and Mars. Some orbit close to their stars, enduring scorching temperatures, while others orbit farther out in the habitable zone where liquid water could exist. The Kepler Space Telescope has been instrumental in the discovery of exoplanets. By observing the slight dimming of stars as planets pass in front of them, Kepler has identified thousands of potential exoplanets. One of the most intriguing exoplanets is Segment 5. The Wonders of Exoplanets continued. One of the most intriguing exoplanets is Kepler-186f, located about 500 light-years away in the constellation Cygnus. Kepler-186f is similar in size to Earth and orbits within its star. This means it could potentially have liquid water on its surface, making it a prime candidate in the search for life beyond our solar system. Another fascinating exoplanet is TRAPPIST-1e, one of 7 Earth-sized planets orbiting the ultra-cool dwarf star TRAPPIST-1, located about 40 light-years away. These planets are tightly packed in their orbits, and at least 3 of them are within the habitable zone, raising the possibility of finding signs of life. Hot Jupiters are a class of exoplanets that orbit very close to their stars, resulting in extremely high surface temperatures. One example is 51 Pegasi b, the first exoplanet discovered around a sun-like star. These gas giants challenge our understanding of planetary formation, as they are much closer to their stars than we would expect for such massive planets. Rogue planets are another intriguing type of exoplanet. These planets do not orbit any star and wander through space independently. Their origins and characteristics are still a mystery, but they add to the diversity of planetary systems in the universe. The study of exoplanets is a rapidly evolving field, with new discoveries made regularly. As technology advances, we may one day find an Earth-like planet with conditions suitable for life further expanding our understanding of the universe. Segment 6. Cosmic Phenomena. Space is filled with fascinating and sometimes mysterious phenomena that captivate our imaginations. Let's explore some of the most intriguing cosmic events. Auroras, also known as the Northern and Southern Lights, are natural light displays that occur near the poles of planets with magnetic fields. On Earth, they are caused by charged particles from the sun interacting with our planet's magnetic field. The result is a stunning display of colorful lights dancing across the sky. Eclipses are another captivating phenomenon. A solar eclipse occurs when the moon passes between the Earth and the sun, temporarily blocking the sun's light. A lunar eclipse happens when the Earth passes between the sun and the moon, casting a shadow on the moon. Both types of eclipses offer a spectacular sight and have been observed and studied by humans for millennia. Meteor showers are events where numerous meteors or shooting stars streak across the night sky. They occur when the Earth passes through the debris left by a comet. One of the most famous meteor showers is the Perseids, which peak in mid-August and provide a dazzling display of meteors. Supernovae are among the most powerful and dramatic events in the universe. When a massive star exhausts its fuel, it can explode in a supernova, releasing an enormous amount of energy and outshining entire galaxies. Supernovae play a crucial role in the universe by dispersing heavy elements into space, which can later form new stars and planets. Nebulae are vast clouds of gas and dust that are often the birthplaces of stars. The Eagle Nebula, for example, contains the famous pillars of creation, towering structures of gas and dust illuminated by young, bright stars. Nebulae come in various shapes and sizes, each with its own unique beauty. Quasars are extremely bright and distant objects powered by supermassive black holes at the centers of galaxies. They emit incredible amounts of energy, sometimes outshining entire galaxies. Quasars provide valuable insights into the early universe and the formation of galaxies. These cosmic phenomena remind us of the dynamic and ever-changing nature of the universe, offering endless opportunities for observation and discovery.